Hello everybody. In this Python tutorial, we're going to go over how to use the net present value function. Before we get started, we're going to go over a few notes. However, if you'd like to skip the notes, you can probably skip about the first 2 minutes and 15 seconds of this tutorial. Okay, so let's go ahead and go over our notes. Net present value, or NPV, is the difference between the present value of cash inflows, that would be income or returns, and the present value of cash outflows, that would be, for example, investment costs. NPV is calculated using a predetermined discount rate. NPV is often used to analyze the profitability of a potential investment or project and/or to help business leaders choose between projects. A project or investment is acceptable if the NPV is positive. When using the discount rate and discounting methods, think of discounting as compounding in reverse. Common ways to determine the discount rate include using the expected return of other investment choices with a similar level of risk or similar finance costs to fund the project. Key steps in calculating NPV include 1. Determining future cash flows, and make a special note that to do this correctly or to do this well can be very challenging. And 2. Determining the discount rate. Synonyms or related terms for rate or discount rate include, but are not limited to, required rate of return, hurdle rate, incremental cost of capital, opportunity cost, composite cost of capital, marginal cost of capital, periodic discount rate, and interest rate. A few notes on the specifics of the NPV function. The NPV function returns the net present value of an investment based on a series of potentially irregular cash flows that occur at uniform time intervals, and pay special attention to two parts of that definition, one being the potentially irregular cash flows, and 2 being the part that mentions uniform time intervals. Okay? And one last note on the NPV function. The NumPy, net present value function, requires the investment amount, that would be the outflow or money coming out of your pocket, to be put in the second argument list as the first list item. And we'll go over specifically how to do that in our examples. Okay, so let's go ahead and get started with our first example. Remember to import the NumPy package. We're going to need that to access the net present value function. Okay, so for our first example, you are presented with an investment opportunity. For the first and second years, you expect negative cash flows of $25,000 and $10,000. In the third year, the cash flow is expected to be 0. In the fourth and fifth years, the investment is expected to produce $10,000 and $30,000 positive cash flows. At the end of the sixth year, the investment is expected to produce $100,000 positive cash flow. In order to invest, you want to achieve an annual return of at least 10%. Okay, so here we have all of our cash flows. Just like we mentioned in our example here, we've taken all of the inflows and outflows and assigned them to variables. So year 1, cash flow, that's a negative cash flow of $25,000. Year 2 is negative $10,000. Year 3 is 0. Year 4 is $10,000. That's a positive cash flow. And years 5 and 6 are positive cash flows of $30,000 and $100,000. Another thing that we're going to need for our net present value function is the discount rate. We have assigned that value here. And as we mentioned in our example, we want at least 10%. Okay, so we put that as a decimal. And our initial investment in this first example is assigned here, and we have set that equal to 0. Okay, so let's scroll down a little bit here. And as we mentioned in our notes, values must begin with the initial investment. Now this might be a little bit different than what you're used to if you're used to using a spreadsheet function to calculate NPV. Okay, so we'll go over specifically how to do that here in just a second. So the first thing we did is we created a variable. We called this NPV1. Then we accessed the NumPy package, and we use a dot to access the NPV net present value function. Inside the net present value function round brackets, this is where we're going to put our arguments. Okay, so let's go ahead and put in our arguments, and you can see the pop-up says the first argument is the rate. That would be the discount rate. And then the next argument is a set of arguments, and those will be our cash flow values. So let's go ahead and put in our rate. So the variable name for our rate is 1 discount rate. Remember, that's the 10%. Now let's put a comma, and let's create a list to put all of our cash flow values in. Now remember, the first value in our list must be our initial investment. That would be this value right here. Okay? So let's go ahead and put that in as our first value in our list. And as we said, for this first example, that's just going to be a 0. Now let's go ahead and put in all of our cash flows. And we're going to put these in order from year 1 to year 6. Okay, so we've put in all of our arguments. Just to recap, the first argument is the rate. We put that in here. And the second argument is a list of all of our cash flow values here. And remember that the first element in the second argument list needs to be the initial investment. Now, one thing before we move on, if you're using the Spider IDE, in most cases, you should be able to click on the function and hit Command I, and you get a little help screen over here. And this will give you information about the net present value function. And if you ever need to review the argument requirements, you can see over here, it gives you a little reminder that says values must begin with the initial investment. Thus, the values in the list, that would be the first value, index 0, will typically be negative. Okay? So then the next thing we did, so we can display the outcome of our net present value function, is we created a print, and we did a little bit of fancy formatting here just to put that in the currency format. So basically we took our variable here, we stuck it inside of a print with some fancy formatting, and now we can go ahead and select our code and print it to the console and see what we get for our outcome. Okay, so you can see over here in the console, we get our net present value, and the outcome is $50,913.43. Okay, so how do you interpret that? Well, as we mentioned in our notes, typically, if the net present value is positive, it is acceptable. Now, there's all kinds of other things that can go into what types of investments and projects you choose, and NPV is just one thing to help you make those decisions, but typically, if it is positive, it is acceptable. Now, one thing you'll notice is that our initial investment in this example is 0, and that might not typically be the case. However, in this case, we just went ahead and gave the initial investment a value of 0. So maybe there's not a lot of equipment you need to buy or things that you need to purchase to get the project up and going. Maybe it's just labor and you've figured that into your future cash flows. But in this case, if the required initial investment is 0 or it is less than this amount here, this opportunity meets your 10% goal. Okay, so let's move on now to example number 2. Okay, so the goal of this example is to see if the project generates more than it costs in present value terms. For our discount rate, we're using 10% again. In this case, we do have an initial investment, and before we can get this project started, or before we can fully invest, we need to put out $10,000. Okay? We've estimated our year 1 cash flow to be $2,000, our year 2 cash flow to be $2,000. These are all positive cash flows. Our year 3 to be $4,000, our year 4 to be $4,000, and our year 5 to be $5,000. So with an initial investment of $10,000, that's going to come out of our pocket at a discount rate of 10%. With 5 years of cash flows at $2,000, $2,000, $4,000, $4,000, and $5,000, let's go ahead and plug all of those arguments into our net present value function. So the first argument is the rate, so that's going to be the discount rate of 10%. Our second argument is going to be all of our cash flows, and that includes the initial investment. So we're going to put that inside of a list. Let's put our initial investment first. And now we can put all of our cash flows in order from years 1 through 5. Okay, again, here we've gone ahead and put our net present value 2 inside our print with some fancy formatting to put this in currency form. So let's go ahead and select all of our code and run it. And you can see over here in the console, we get a net present value of $2,312.99. Now, the first thing to notice is that this NPV is positive, so that's a good sign. And as we said before, the goal for this example is to see if this project generates more than it costs in present value terms. And after plugging in our discount rate, our initial investment, in all of our cash flows, it does indeed appear to generate more than it costs. So with that criteria alone, you might say this is an acceptable project. However, there are always more things that go into the decision-making process, and you may have other projects that will actually return more. Okay, so those are just a few examples of how to use the net present value function. That's all we have for this tutorial. We will be doing many more Python tutorials in the near future. Join us for those, and we'll see you next time.